Okay, in this tutorial, we're going to examine how to conduct a field study for Soil Study 1. Now, this is likely to be a field study like you have actually experienced on a field trip, where you gathered soil samples from a slope. The actual context of the question is that a group of students are planning on conducting a soil study on a hillside. They are interested in how the altitude, that's the height above sea level, and the gradient, which is the angle of the slope, influence key soil characteristics. Question 1 says write a suitable hypothesis that could be used to test the relationship between one of the independent variables and a dependent variable. Now, to answer this question, the first thing you have to do is understand what's the difference between an independent and a dependent variable. An independent variable is something that cannot be influenced by something else. So, for example, height above sea level cannot be influenced by anything else, by the soil or the land use or anything. It is the height above sea level. Likewise, the gradient of a slope is not influenced by somebody else. You can't change the gradient of the slope just because you plant a different crop on a field. So these are fixed in place. They might change through massive geological processes with the uplifting of land over millions of years, but obviously that's a very slow process. So we consider these to be independent, and we're interested in how these independent variables affect what we call dependent variables. So in the case of a slope that has a certain angle, and obviously at the top of the slope you're higher above sea level than you are lower, those two variables are possibly going to affect something to do with the soil. Okay, so what you would then need to think is, how could the soil change? What soil characteristic is likely to change because there is a change in height above sea level? Now, height above sea level is going to affect temperature. So the higher up you are, the more likely you are to be exposed and at a lower temperature. This might in turn affect what grows on that landscape because there's a difference in temperature, which might in turn affect the soil because, of course, what grows on a landscape influences the soil that develops. And when we think about the soil characteristic, we might therefore be talking about maybe the organic content or the pH or the moisture content. All of these things might change the higher up above sea you are. So that would be testing the altitude. Likewise, the gradient, the slope, that could also influence soil characteristics, especially because steeper gradients are going to have much quicker mass movements because of gravity rather than flatter gradients. And therefore, wherever we encounter steeper gradients, we might find that the soil that develops on them has got some very different characteristics, different amount of moisture, potentially different organic content, different soil depth. It's unlikely you're going to get very deep soil on a steep slope. So think about which variable you want for the independent variable. You've got a choice of two. Select a soil characteristic, any soil characteristic, and tell me what the hypothesis is. What you should do once you've written the hypothesis, so what you believe will happen, so either as the altitude increases or gets higher or the gradient increases, what do you hypothesize is going to happen to the dependent variable? You should also explain why you think that's going to happen. So a sentence actually says the steeper the slope will cause whatever soil characteristic is you've picked to change in this way. You'd want to say why. Right, let's move on to question number 2. This is a key exam question. So explain how you would gather relevant data for this soil analysis. Okay, you should explain 2 gathering techniques and a sampling methodology in your answer. So let's start with a sampling methodology. Let's have a little look at some photographs. Now, if we are going to conduct a gradient and a altitude study and see how it influences soil, we're clearly going to have to select a location where there is a change in gradient, as shown in this photograph. And what this photograph shows us is a slope with the students at the bottom of that slope. So the first important thing in your sampling methodology is that in order to study changes in gradient and altitude, you're going to have to find a location where there is a noticeable change in both the altitude and the gradient. And that means that you're going to have to be stratified. You can't just go anywhere. You have to go to a place where those conditions exist. You're also going to want a slope that has a reasonable change in height from the bottom to the top. So it can't just be 5 or 10 meters. You need a hillside that's got a noticeable change in height in order to have a real understanding of whether altitude is likely to influence. So you're probably going to be needing at least a couple of hundred meters of change in altitude to really see if altitude is influencing the soil. Likewise, you're going to want a slope that's got a variation in gradients, because if it's all got the same gradient, if it's all 5-degree angles, well then you're not going to be able to see if change in gradient in somehow influenced a change in a soil characteristic. The next thing you're going to want to do is consider using a line transect. Now, why would you do a line transect up the slope? Because it allows you to see change along the line. As the slope changes in height and gradient, so will the soil characteristic possibly change. And a line transect makes that easy to study. As you move up the slope, you're going to want to select sampling locations to take your soil samples. So how do you select them? Are they equally spaced along the transect every 5 or 10 meters? That is one option. That makes it easy to gather the data. You're probably going to look for 10-meter differences because there's not likely to be a big gradient change over a very short distance. So to get a gradient change, you need enough distance between the two sample locations, as shown by the two ranging poles. Secondly, you need enough change for there to actually be a change. If you were doing it every meter, it's unlikely the soil is going to change very much. So there needs to be enough distance between each sample location to ensure change. Are you going to go with equal distances? You might do. Or you might actually go for equal heights above sea level. So if you had a GPS device, you could actually record the height above sea level. Let's say right here we are at 100 meters. And then as you walk up the slope, you keep walking until you've gone up 5 meters or 10 meters. And then you stop and you get soil from that location. And then you walk up another 10 meters and get a soil sample from that location. And so on all the way up the slope. Another key consideration is to ensure you have enough soil samples to actually study this and do statistical samples. So you're probably going to be looking for somewhere between 8 to 10, a minimum of 8 to 10 soil samples to ensure you can see change, that you can see variations on the slope, and that you've got enough to do a statistical test at a later point. For example, a Pearson's test might be conducted if you had enough soil samples to do so, which is why you might choose to do 8 to 10. The key thing, though, is it's probably going to be a systematic sampling strategy. You might need to consider stratified if there are obstacles, if there are certain places on your slope that you cannot gain access to, maybe because of land ownership, somebody owns it and is not allowing you on their land, maybe because it's a hazardous environment and you can't get to it because it's dangerous. So you might need to consider stratified sampling if there are difficulties accessing every location that you've selected using systematic sampling. Right, we're not quite finished though, because once you've selected your sampling strategies, how do you gather your samples and how do you ensure that they are accurate? So you're going to want some equipment. Let's talk about the soil auger first of all. The soil auger is used to get a soil core, and from your sample location, you use the auger to drill a hole. You would drill down till the screw disappears if you're wanting to get a soil sample, and then you would extract the sample, taking soil from, you have to pre-decide which part of the auger you wish to get your sample from. So in this photograph, you can see the tutor taking soil from the bottom third of the soil auger and putting it into a pot. Now, to get accurate data, she would have to consistently take soil from the bottom of the auger to ensure that the soil sample is consistently coming from the same depth. If she took it from up here at one place and down here at another, then she would not be measuring the same depth, and therefore it's likely the soil is going to be different from the surface, which is the soil up here, versus down here, which is about 15 centimeters down. So this ensures a consistent method of gathering the data to get her soil sample. When you get to the classroom, you're going to have to ensure a consistent strategy at analyzing that data, because a soil sample itself is not useful for finding out something about the soil. You have to take it back to the laboratory, and in this case, the soil needs to be weighed. It then, using the microwave testing process, needs to be microwaved, and you can talk about how that could be done, and then reweighed, and then microwaved again and reweighed. And once the weight gets a consistent weight, indicating that all the moisture has evaporated off because it's been in the microwave, then you can calculate the percentage change in moisture. You could also use equipment to test the pH. Digital pH probes could be used to place them, if I show you a photograph of that, to take some dissolved soil content in water and then test the acidity of the water using a pH probe. Why use a digital meter like we can see just here in the background? Because it's going to give you a much higher level of accuracy rather than using, for example, pH paper that you might get in a science laboratory. Okay, now that's one technique. Another technique to use is to get soil depth. So we have a little look at how do we get soil depth. Well, we could drill the auger down until we get to the point where it is at its deepest, until it can drill no further, which means we've got to the sea layer where the rocks are, and then we pull it out and we measure the depth against the ranging pole. The soil auger. So that's another thing. pH measurements can be used using these digital pH probes that we can see in the photograph here. There is one weakness with this, is they can be unreliable and they don't tend to give a high degree of accuracy. It's much better to take a soil sample back to a laboratory and test it using a proper digital pH probe rather than these rather simple devices. However, this would give you some comparative data in the field, which if you went back to the laboratory, you could then test your measurements in the laboratory and see how accurate they were and how similar they were. This would allow you to at least see if there's some degree of accuracy or inaccuracy in your data gathering. What's important in answering this exam question is that every point you make in terms of the sampling that you describe, how you select your site, how you select your transect, how you pick your points on that transect, and whether it's systematic or stratified, that you always ensure it tells you why it allows you to gather relevant and accurate data. Likewise, when you explain the gathering technique, explain actually how you do it, and then tell me how that process ensures that the data you gather is going to be relevant and accurate. You always want to be exploring the reasons you do it in a certain way and not another way, because you're always trying to ensure that your data is high quality. Okay, now go ahead and answer this question.